Good morning from Japan. I see.
練習セッションです。
Good morning. Good morning from Japan. Attention all participants. Thank you all for waiting. Welcome to the Asian Disaster Reduction Center Online Tsunami Seminar this year. Before starting, we would like to make a few announcements regarding your participation in this seminar. First, if you have questions during the lecture, please use the Q&A function at the bottom of the screen. Please note that the chat function is only used to communicate among session speakers. Hence, the Secretariat will not reply to chat messages. Second, presentation materials will be made available on the Tsunami website or Tsunami Seminar website after the seminar. Thank you for waiting. Now we would like to call on Mr. Nakagawa, Executive Director of ADRC, to start the seminar.
Thank you, Nakamura-san. Good morning from Japan to all of you joining us today for ADRC Online Tsunami Seminar. I'm Masaki Nakagawa, today's moderator. So ADRC, together with the Cabinet Office of the Japanese government, have promoted tsunami awareness raising at various occasions. Last year, we started a series of ADRC Online Tsunami Seminar intended to share the latest research findings and expertise by Tsunami DRR experts. So today, we invite an expert from Chile, which is one of the tsunami-prone countries in the world. Professor Mauricio Reyes Gajard, Assistant Professor, University of Valparaiso, Chile, will give a lecture on the experience with tsunami risk reduction in Chile. So as this is a 1-hour seminar, without further ado, let's get started right now. So welcome, Professor Mauricio. The floor is yours.
Thank you very much, Nakagawa-san. Good night for everyone. Here in Chile, it's 10 in the night, so I have to say good night. I will start my presentation. I have to share screen. Wait a minute. Okay. Everything okay? Can you see?
Yes.
Okay. Well, my conference is called Experience with Tsunami Risk Management in Chile. That's me. I am civil engineer. I am one of the lucky guys who studied in Japan. I made a Master of Disaster Management in Tsukuba and in Tokyo and in Ubechi, Yamaguchi-ken. So after that, a couple of years ago, I have been working as a professor in the University of Valparaiso and always related with disaster management from the academic point of view. This picture is the government palace in my country, the Palacio de la Moneda. And that's our flag. And I choose this picture because finally, disaster risk management is a political problem. So the core of the problem is political. In spite of, we are going to talk about physics, mainly physics, but you will see. What are the objectives of this presentation that I would like you to think about this? First is to generate reflections about disaster risk management in Chile and other countries, because we have many things in common. learn about Chile, my country, its context, prehistory, and history. To know the main disasters in this geographical area, especially earthquakes and tsunamis. Have an approach to the measures that Chile has taken to reduce tsunami disaster risk and other disaster risks too, and assimilate and share experience and knowledge, of course. In this draw, I am summarizing something that is very complicated, actually, but it's very simple to see in this draw. We live in a normal condition when everything is okay, and suddenly something happened and we get into a crisis condition. In some places, this crisis condition is solved or solved without military control, with political solutions, or maybe just because of the people that has been well educated and have a good behavior, or there are good services. I don't know, like the case of Japan. In Japan, when there is a crisis condition after an earthquake, you don't see the images that you can see in other countries like looting or something like that. You can see order. But in the major part of countries, especially the poorest one, when the crisis comes, you need military control. So it's a political problem because military control, nobody wants military control. It's too much. It's too much. So it's a big problem. How we control the crisis? To get to a good solution of that. And the way, I think, is from the technical solution to the political solution, but always taking into account the multidisciplinary perspective. It's a very complex problem, as we will see in this conference. And risk management is over here. We need risk management to get in a good way from the normal condition to the crisis condition, and came out in a good way from the crisis condition. So the contents of this presentation first will be disaster risk management. I will talk about some theoretical concept to draw a line. I will talk about my country and the multi-hazard condition. Then I will talk about earthquakes. There are many earthquakes to talk about in Chile. Also tsunamis. Then to reflect about our vulnerabilities, our capacities, and finally a sort of conclusion and a strategic analysis. Chile is a very beautiful country, I have to say. It's famous for that. You have a lot of landscape. It's a very long country, as we will see in the next slides. And we also like soccer. We're famous because of this kind of players like Alexis Sanchez. Maybe you know him. And I choose this image because they're playing against Australia, and I know that many of you probably scream for your countries when they play against Australia. Okay, so let's go. To talk about disaster risk management, first concept is to talk about life and death. It's very easy, that definition, it's very true. Life is a condition of equilibrium. From the ecological point of view, life is possible when an organism has variables of its system, organic system, are in an equilibrium zone, the homeostatic plateau. So with internal controls, the living being can stay in that equilibrium zone. For example, my body temp raise up, so my body start controlling it. If my temp raise up too much, I will die. Okay, the same if the temp is lower than 37 Celsius degree. So it's a an active equilibrium, not a static equilibrium, active equilibrium. And this is the way life functions. All the way all the living beings respond to this behavior. So there is a positive feedback zone and a negative feedback zone. The negative feedback zone is where we can live. If we get into the positive feedback, the destiny is dead. So this is the comfort zone. The comfort zone is life between born and death, okay? And life is possible in this world with the conditions of this universe, where are many uncertainties and there are strong laws that control the context where life is possible. So let's analyze a little bit more deeper. Let's analyze things regarding to time, people, and place, and law. This is not mine. This belongs to a friend that is already dead, but he always used to say, let's analyze it. Time, people, and place for everything. Time pass through, we can't stop it. We are at the end of the line of time, or timeline. We have a long geological history. The Earth has millions, thousands of millions of years, thousands of millions of evolution, and it's a hot ball that is cooling down, okay? And in the surface of this hot ball, there were life, several forms of life, as we can see over here. At temperatures, the average temperature has been varying a lot, but stabilized at the end until the human being come here. If we put 10 years of earthquakes in a video, we have this. We can be the draw of the seismogenic areas or lines or zone, whatever. So this is easy to see if we compress time. What I mean, that we have to be aware of time scales. The problems that are usually related with natural disasters, especially earthquakes, tsunamis, they have to be measured in geological terms, not in human terms. I mean, it's recurrence, it's recurrent. And if you see the whole picture in the timeline, they are very frequent events. So don't forget that, because part of the complexity of the problem of tsunami risk or disaster risk management is the time scale. We have to be aware of that. People, the same draw. There is people at the end of the timeline, at the very end of the timeline. People, human beings, spread over the world very fast, and we are a lot. You can see an exponential behavior here in this yellow line, an exponential behavior in this first video until the 0 year, the year of the Christ born, the year 0. So you see exponentially growing. And here after Christ, the exponentially, the last number of the first video, we cannot see it, it's just a point. And we have another exponentially grown up. So we have to be aware of that. We are too much people in the world, we are saturated in the world, our cities are saturated, we will have problems, we have problems with energy, with food, and we are complex. We people are complex. So we have to be aware of people things. We have to consider the disciplines, the scientific disciplines that are focusing the human beings, sociology, psychology, and all that stuff, politics, economics, blah, 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 blah. We need multidisciplinary perspective to face the complexity of this challenge. So we have time, we have people. And place. This is the Earth. This is all the water in the surface, all the water. The Earth has 12,000 kilometers of diameter, 13,000. The average ocean depth, 4 kilometers. Maximum of ocean depth, 11 kilometers. Highest breathable air, 8 kilometers. So we have here 13,000, and we have to mark over here 4 units and 8 units. So we cannot see the ocean over here. What I'm trying to explain is that we live in a big rock, but in the surface, a thin layer, a couple of thin layers, the biosphere, the hydrosphere, and the atmosphere, but thin layers, very thin layers. The paint in the surface of this basketball, okay? And we are a rock floating in the space, as in this picture taken by the Voyager. Looking back, that little point, pale blue dot, that's our planet. No more planets, no other planets. It's the only planet we have. All the history, as Carl Sagan said, all the history, everything you know, everything is in this little point. And not just that little point. It's a rock in the surface of that rock. And in that thin layers, we have all these processes, physical processes that define the conditions that made this planet available for life. Even the tectonic behavior of the surface of the planet, of the crust, just the crust, a layer, 100 kilometers, 200 kilometers maybe, a layer, just a layer, okay? So we have to be aware of our position in the universe, okay? We have to be humble to face the complexity of the disaster risk management challenge. And finally, law. Two laws for this case. First, thermodynamics. Energy can neither be created nor destroyed, only convert from one form of energy to another. And if there's no work, the energy will disperse. If you put, I don't know, you can put this bell in the sun, it will get hot. But if you move it to the shadow, it will cool down. Energy disperses. So all the physical process that we can see, watch, there is energy involved. And energy has a behavior defined by law. Disperse. Look for more chaos. Okay? So, as the planet is cooling down, there have to be movement. And when two plates are locked and they release, there have to be heat, vibration, sound, and all the possible forms of energy that energy that the planet has will disperse. Okay? It's a law. As the gravity law. Everything goes down in there on the Earth. Okay? So we cannot escape from that. Okay? It's physics. It's a law. So with that in mind, it's very easy to understand that earthquakes, tsunami, and climate change, and all that physical hazards that we talk about, all that is absolutely logical to happen and to be recurrent, because we have energy, and energy needs to dissipate. It's a law, okay? Let's put the ball on the ground. That's what we say, okay? Let's start playing. This is a very good player. What we need as a ground is the definition of risk. I choose the IPCC definition over here. There are many definitions, a lot. The potential of adverse consequences for human or ecological systems, recognizing the diversity of values and objectives associated with such systems. Very brief definition, very complex definition. Each word over here must be open to have a fully understanding of this concept. But we can summarize it, giving it 4 characteristics: uncertainty, damage, losses, and death. Risk is associated with the potential of damage, losses, and death, but it's uncertain. If you have certain, there is no risk. If you know that in 15 minutes will be an earthquake over here, there is no risk for me. I have to go out to stay in a safe place, and my risk is almost 0. Okay, so a part of risk is not to know when it's going to happen, where it's going to happen, how it's going to happen, any hazard. Okay, and in terms of mathematics, we can formulate it as probability of occurrence multiplied by impact. And this is a very good definition, because the probability of occurrence is something that we can obtain from what we know. And we can have some trust on that, but not so much, because we don't know everything. So any statistical analysis is not valid for some hazards. Maybe it was for rain when there was no climate change. But for earthquakes, it's not the best way to forecast. Not to share on. We cannot trust in probabilities so much. Whatever. The other factor is impact, and impact can be very, very, very complex, because human systems are complex. So you can define impact as human impact, economic impact, ecological impact, social impact, a lot of definitions. And we can put this equation into a matrix, very easy to apply. This matrix comes from the military work. The first publication about this, the use of risk matrix, come from the US Air Force. And many military branches in several countries use this kind of risk matrix. At least in Chile, it's very used. And you have low risk for very low probability and negligible impact, and high tolerable risk for severe impact and very high probability. So in these cases, you will go from normality to crisis, as we talked before. And that is life. To get out from the comfort zone, to get out from the negative feedback zone, to get out from the equilibrium zone. What do I have to remark about risk? First, it's multi-hazard. It's impossible to separate from other hazards. One hazard or no other hazard. Tsunami, okay, with or without pandemic. Tsunami, with or without rain. There is less probability to have a combined hazard. Okay, I agree. But nobody can say that we will not have a combination of hazards. Okay? So keep always in mind that we need a multi-hazard approach. Second, very important, multidimensional impact. As I said, human, economic, ecological, blah, blah, blah. And that, and this can allow us to define or understand vulnerability also as a multidimensional variable. So it's very hard to manage such a complex variable, okay? Very complex. Finally, some authors say that this is dependent of this, or they can add capacity or exposure and make the factor more complex to analyze. But I think with this three concepts in mind, we can keep going forward. Now let's talk about Chile. I'm okay in time. This picture is from the tsunami 2010, was a kind of symbolic picture. That for that tsunami, there were some of the first generations mobile phones with camera. So was a very, very media influence disaster. And this is Santiago, that's smoke, very polluted city. Here's a timeline. My country was discovered by Spaniards in 1536. They were looking for gold. They found very few gold in Chile. Our independence was in 1810. There were some important issues, war against Peru and Bolivia, and we won big territories in the northern part of the country. The annex of Easter Island, a civil war in Chile, a military coup in 1973, and back to democracy in 1990. Here's the discoveries, the first government, the war, the military coup, and I can say that Chile is a young country, historically and geologically. Historically, because the inhabitants of Chile before the Spaniards, they have no written language. So history starts with the Spaniards because they wrote what they live, okay? And geologically, it's very new, not more than 550 million years in some very specific rocks. So it's a young country. And very important for disaster risk is our economic development. You can see over here two graphs with the GDP, the gross product. And you can see how much it grew up in the last 30 years after the return to democracy. There is a very strong phenomena. The military government over here designed a very capitalist system economy. And when the people came back to democracy, many of the politics were in exile during this government, and they were in Europe, mainly in Europe and United States. So they came back with a lot of new knowledge, and the economy rose up. That's the main point. Where there were a very good political administration in terms of economy, and the country grows up and became a rich country. We are rich in terms of natural resources, but we are not a developed country because we are not generating so much technology. Our economy is based on in commodities. Okay, copper, for example, lithium. This is the GDP of Chile compared with other countries. In South America, we have the highest one. We are located here. It's a long and narrow country. There is Easter Island, and we have not sovereignty, but we are part of the Antarctic treatment. So we have jurisdiction over this part. It's a very big country. We have responsibility in this pale blue triangle. In case of an accident or something like that, it's the Chilean army that has to go there. You can see here. if we compare Chile now with the south in the top with other places in the world, you can see that it's a very long country, very different climates. You can compare with Europe, with Asia. Here's the same, the analog tropic and circle, and with North America, from Mexico to Canada to Alaska almost. Here in the southern hemisphere, comparing with Australia, New Zealand, and South Africa. Okay, and if we take a polar view, it's very different, and it's very important. Chile over here, it's almost together with Argentina, Australia, New Zealand, the only countries closer to the Antarctic continent, and dominating a vast ocean. It's a very maritime country. Okay, we're very influenced by sea. Our weather is dry in the north part. This is a draw a friend of mine made. Draw. Dry, not so dry, but fertile. In the middle part of the country is very fertile, Mediterranean conditions. Cold and rainy over here, very cold, windy, snowy over here with fjords and cold weather. And here, it's a much cooler weather. And in Easter Island, it's almost tropical. We have population concentrated in urban areas over here in the north part of the country because it's a desert. So the people is in the cities where there is water. It's very important in economic terms, and there is a lack of water. It's a desert. This is the part of the country that we won, in the war against Peru and Bolivia. The central part of this country has the higher density of inhabitants. It's a core economical and agricultural meaning, and it's subject to a severe drought due to climate change. And in the southern part, there is a very low population density and not so big cities, just one or two over here. Over here, not so much cities. It's very wild. That was the population of Chile, the population pyramid when I born. More young people than older. This is now in the middle age. There is more people, and in the future, more old people, more elderly people than young people. So the people is very important to consider in tsunami disaster risk on disaster risk management, because the people is changing, not only in number, also in composition and in culture. So it's a dynamic problem. 19 million people, 8 million in Santiago, $25,000 per capita. Oh, that's a lot of money. Yes, but it's per capita. It's not well distributed. Another very important thing, one main language. In spite of being a large country, we all speak the same language. So it's easy to communicate. It's a multi-hazard country. Here are some examples. You can look for more information in these two websites. It's an atlas of climate and other risk that you can see the exposed areas. Here, one example in the northern part of the country, Arica. This is a limit with Peru. There is a volcano. You can see these big canyons. It's a desert over here, but in the highlands, because this is going up, and here there are highlands, very high, 5,000 meters. During our summer, in this time of the year, February, March, there is a lot of rain over here, and the water goes through the desert, eroding it. So that's why there are so many scars over here. And here you can see also here the tsunami evacuation map. That's Arica, we have volcano, Chaitén over here, 2 volcanoes, Valparaíso, Viña del Mar, tsunami, and over here in Valdivia, tsunami. Okay, I'm not looking in detail. Over here Arica, over here Valparaíso, over here Valdivia. And you can also visit this ONEMI. ONEMI is the National Office for Emergency. Oficina Nacional de Emergencias del Ministerio del Interior. National Emergency Office of the Ministry of Interior. Okay, and they have these maps. Chile is a large country, not so populated as you see, but with vulnerabilities and under the threat of several hazards. I just mentioned 3: tsunami, volcano, rain, 4: drought, pandemic, 5, and much more. Chile is one of the very high risk country in the world, according to this study. Very high risk. Let's talk about prehistory. That the previous slide is a mistake. It should not be here. Before the Spaniards arrived to America, this was the countries there were, tribes. Influence on Chile is here. Was very influenced by the Tahuantinsuyo, was the Inca Empire. The Inca lived in Peru and Bolivia. And they have a very strong culture, language, and wiseness. The Mapuche people who live in Chile, they used to say that there were 2 snakes fighting. Here we can see the Earth surface. Here, Chile, the Cordillera over here, the trench, Nazca Plate over here. We are looking to the north. The South American plate over here. The Nazca Plate is getting into the South American plate, as we can see here. The elevation profile shows us perfectly, very clear how the Nazca Plate is getting into the South American plate. Of course, the height over here is very exaggerated. So Mapuche people say 2 snakes, Kai Kai Vilu and Tren Tren Vilu, fight. And when they fight, the Kai Kai Vilu, the snake from the ocean, tries to get over the Tren Tren Vilu, the snake from the land. So Tren Tren Vilu curve its body for the people to climb up and be safe from the Kai Kai Vilu. So that's the legend that they used to represent the earthquake and tsunami. So in their tradition, the Mapuche people always have some sacred hills that were used to evacuate in case of fighting of their godness, these big snakes. So no written language. That's the prehistory. Another way to know prehistory is the paleo-tsunami analysis. And here you have some pictures. This is from Chile, and this is from Indonesia. The professor over here, Marcos Esterna, allowed me to use this picture because she was a student of him. And she discovered the tsunami traces, ancient tsunami traces in Indonesia. But this is in Chile. And there are several points in the world where you can find this sand that tsunami move into the land. And under certain conditions, especially water and plants, organic matter, the soil start growing upon this tsunami sand. And when time passes through, you can dig in, extract from here some vegetables or other things that are analyzed, and you can find the year when this tsunami happens. So with that, you can extend the earthquake and tsunami record more than what history says. In Japan, in Sendai, there is a lot of knowledge about this. Also in Cascadia, in Oregon. And in Chile, we have 2 places where we have found this kind of signals. Okay, so it's very important. In terms of history, after the discovering of our country, we have the records of the Spaniards. they came into Chile looking for gold. First, they have to walk through the driest desert. Almost a half died in the road. And they came here, they found some Aboriginal people, some very brave, another not so, but not so much gold. So was not so good business to come here in the first years. But the wars, they came here after they defeat some tribes, they start building fortifications, then they start building houses, cities, with the techniques, the building techniques that they were bringing from Europe. And here we have earthquakes. So everything they built, an earthquake wipe out. Okay, so it was very difficult for the Spaniards to learn how to build here in Chile, but they finally found a way. And we have our old infrastructure, the adobe houses in Chile are made with adobe and wood. They learn to put the diagonal braces between the adobe blocks. So they were successful with that. Not so much, but they were successful. The cities resist 100 years earthquakes. But anyways, our cities are almost fully demolished. You go to our cities and you cannot see so many old buildings. Oh, there's always an earthquake that destroys them. Okay, and you can see here the historical record of earthquakes since the first records until now, and you can see much more earthquakes over here. That is just because the population density and in this part and the availability of technology, because here is when we start recording the earthquakes. We have a very strong earthquake in 1906 that destroyed the main port of Chile, Valparaiso. And after that, the government asked help to France, and France sent a scientific to start studying earthquakes in Chile. And we have now a seismological center, very good. It dependent on it's a dependence of the University of Chile. And they have a very good information center. I will talk about later. So in terms of history, this is Chile, and here are the earthquakes that we know, and approximately what we know about the rupture length. Okay, there are many gaps, and we have the biggest one, 1960 earthquakes. I will talk about later. But the main point is that just in the last year, we have technological advances. We have a national seismologic network, a tidal seismologic network. I'm sorry, this is in Spanish. And a big jump in the last years because we have early warning system for tsunamis, especially, and for climate hazard also. And we have history and paleoseismology, things that were not here 30 years ago. And history is very important. Why? Because with technology, we can measure, monitor, forecast, and communicate. We can research and we can educate. And research, internet is very important for the research. That's why I put Google over here. Because as Chile is very far from Spain, during a part of our history, in Spain, they were receiving letters saying that, hey, here was an earthquake, I don't know. So we built our earthquake database with the information in Chile until internet. With internet, historians can research more, and they went to Peru and to Spain to read the old letters that the people in Chile sent to the king or the vice king, whatever, and they find out that some earthquakes were bigger than what we thought, and that there were some earthquakes that we didn't know there were, and all that stuff. Okay, technology. After 2010, the government made big investments, and also with the help of very important, several countries, especially Japan. Arigato gozaimasu, Japan, because they give us a lot of information. They gave us a lot of knowledge, and now in Chile we have a scientific critical mass. You know, we have scientists working on these things, and the seismological network has grown up. We have GPS stations, a lot. We have seismometers, accelerometers, things that we didn't have 10 years ago. Maybe some 40, I don't know, 20. Little numbers for such a long country as Chile. And not only long, we have continental area, we have islands, not only Easter Island, also Juan Fernandez Island, and we have people in the Antarctic territory. So we need to protect them all. Okay, so in the central part of Chile, I'm sorry, I cannot talk about all the earthquakes in Chile. We have this series of earthquakes, and 1730 has been discovered, thanks to history and paleotsunami, that it was 9.1 magnitude and not 8.5. So we have an underestimation of hazard over here. What can happen? We have to be prepared. Main earthquakes: Chillán, 1939, 8.3, inland without tsunami, 24,000 victims, the biggest one in terms of victims. After that, we cannot build masonry over here without reinforcement. It's forbidden. You cannot build a house just with brick. No, you have to put reinforced concrete between the bricks or surrounding the bricks. They create the core. It's a part of the state that helped in rebuilding the country, and now it's very important for economic improvement, for industry, and this building generate the first building code. Valdivia, 1960, the foreshock was 8.2. The earthquake was 9.5 measured in other places of the world, thanks to the Cold War. The Cold War, because the big powers had seismograph to detect atomic drills from the enemy. So that generates a big network, world network of seismometers, and they measure this earthquake. We have no seismometers in Chile for that year. Generate a big tsunami. You can see here the big tsunami. Compared with other two tsunamis, this is 2010 and this is 2015, and 1960 is very big. Around 2,000 victims, very few. People escaped to the hills. That's Mapuche area. That was in the culture of the people to go to the hills. And we learn a lot about soil mechanics. It generates the National Office of Emergency, and it also generates the Pacific Tsunami Warning Center. Very important in terms of tsunami risk disaster management. Jojeo, 1985, not so big, 7.8. This is not so big for us. I know this is a big earthquake anywhere in the world, but not so big for us because the major part of these earthquakes, not Chillán. Chillán was inland, but these earthquakes are quite far from the cities. So we feel the P wave usually first. So that's a early warning system, natural early warning system. So usually we can escape from the houses because we have this 15, 20 seconds So maybe that's why we have not so much victims, and thanks to the building codes, not so much infrastructural damage. A lot, but not so much for that size of earthquakes. This was the first earthquake measured in Chile with instruments in Chile. It generates the first, not generates, it was the best test for our building code. Then N is a normalization, norma. It's a code, Chilean norm about building seismic resistant design for buildings, and also improve the organization of the state in terms of emergency management. The big one, the last big one, 2010, 27th February, very important earthquake because we have more awareness after the Sumatra tsunami, the Boxing Day, 2004. So we're more aware of tsunami, and it was a very big one. The earth moved, the crust moved. The GPS showed big displacements. There were a gap. This image is from a study before the earthquake, years before, saying probably here can be an earthquake. And here you can see an island, just the same phenomena that we see in this animation. The island is move up. Yeah? I don't remember the word in English. It's not, well, the land gets higher over here, and you can see white things over here. White, that's the alga and other plants, alga, fixed to the rock under the water, but after the water retreat, it turns white, okay? We learn a lot with this earthquake. We improve our building code in terms of soil mechanics. We had liquefaction and some failure of buildings because of not completely accurate geotechnical studies before the design of the building. Also, we have to change some aspect of the reinforced concrete design code. There were two problems in the connection of bars and in the hint at the end of the walls. So there was very little things in terms of construction. Not important in the cost of the building, just design. And there is a hinge in the armor, the steel armor for concrete reinforced concrete walls that we have to correct to reinforce, because that was a problem that generates the failure of some buildings. The ONEMI, the National Office of Emergency, finally was changed, and a law project get into the parliament to generate this management office, not emergency. I'm sorry, risk management office, not emergency management. It's different, okay? But that law project remained in the Congress for more than 10 years. Last year, it was approved. It was a very big issue, very bureaucratic. Why? Because the Ministry of Interior is a ministry of politics, and an emergency is very good for politics. If a president has a very good management of an emergency, the streets will have his name, the main street, okay? So there is a very important political issue over there. But we learn, and now we will have the Civil Protection Agency, something like that. And also this was very important, this earthquake, because our tsunami alert system, Sistema Nacional de Alerta de Maremotos, Tsunami National Alert System, it failed, and the government at that moment failed. I'm sorry, how much time do I have left?
7 minutes.
7? Okay, I will talk about this earthquake later. Northern Chile, 2014, 8.2 with tsunami, 7 dead, 200 injured in Iquique. After the first big earthquake after the 2010, and now we correct the early warning system, and the evacuation was performed, but in the whole country, the 4,000 kilometers of Chile, of course, shoreline in Chile, everybody has to escape, and our evacuation is till 30 meters over sea level. Doesn't matter the inundation map, no. Everybody has to go to 13 meters over sea level. In case if the system fail, we prevent in that case. And there were evacuation, very few people dead, not so much damage. And we learned a lot with Port BCP. For that earthquake, we were working together with Japanese scientists in business continuity planning for ports, and in the port of Iquique, we were applying it. So it was very useful for the recovery of operations. In 2015, we have another 8.4 in Illapel, in the middle north Chile. It generated a tsunami. I don't think this is number. I think was 2 dead. Here's 6 and 1 in Argentina. Again, the evacuation was pretty good, but we learned that tsunami can arrive in less than 10 minutes to the shoreline, not 15, not 20, no. This was very close rupture zone, close to the shoreline, and some places the water became inundating before the earthquake finished. So that turned on the red lights, very dangerous. In terms of tsunami, I have to mention ICEN 2007, that this is an important point, because there are fjords, and there were a landslide, very big landslide that generates a tsunami. So this was the first tsunami in Chile after 1960. And was a very important issue to study. And we learn, now we know that we are not aware enough, maybe, I think, to cortical failures, shallow earthquakes. This was a shallow earthquake, 6.2 magnitude, but it generates landslide, tsunami, dead people. Okay, we have the national system of tsunami alerts and the CPAT, and this is the most new invention. We divide the country in several regions in terms of evacuation. And when an earthquake occurs, we have easily the epicenter position. And in the office that administrates this thing, the SHOA, that belongs to the Army, the Navy, I'm sorry, they have pre-modeled tsunamis. So with the geographical location of the epicenter, they can find out which preload tsunami represents the real tsunami that will happen, and so they can define an evacuation more localized, not the whole country. Now, depending on the earthquake, you don't need to evacuate if you are 2,000 kilometers far away. But in 1960, there were no early warning system. In Yoyeo, we didn't think about tsunami. Luckily, we didn't have tsunami. In Maule, we learned about tsunami. There were mistakes, operational mistakes. The office in charge of giving the alert were confused because the epicenter was in the shoreline, but I don't know, 10 kilometers inside the shoreline. So the logical function was epicenter in the sea, tsunami. Epicenter in the land, no tsunami. in the land, no tsunami. But the rupture zone was all under the sea, so it generates a tsunami. Very big mistake. A lot of people died because of that. Iquique, I told you about, was not a big tsunami, but there, over here was something very important. Little damage, some meters over here, but the name of the one tugboat was damaged, and they lose the tugboat because it remains in a rock. After a tsunami, you need the tugboats. Those boats can fight a fire, can rescue people, can move a ship, a big ship. So you cannot lose a tugboat. That's a very important lesson from that tsunami. Illapel, I told you, the fast tsunami arrival. Chiloé, this was an earthquake 7.4, but with alert of tsunami. And with that earthquake, the evacuation was located over there, not the whole country. It was very efficient. Antarctic Ocean in January 2021 was a very big mistake of the system, because the early warning system came through the mobile phone with an SMS message and some alerts. And there were an earthquake in the Antarctic area, very far from Chile. And let me show you. I'm finishing. Over here. Like here. So they have the alert system for evacuation of the shoreline in the Antarctic area. But something happened that the evacuation order was sent to the whole country. And together with that, here, almost at the same time when the message was sent, there was a strong earthquake, maybe 6 over here in the Cordillera, over here, close to Santiago. And the people was awake with that earthquake. It was in the night. So you felt a big earthquake and you received a tsunami evacuation order. So it was a very confusing situation. Was a mistake. Was a mistake because they don't need to send a message to the whole country. And Tonga was a very of course, we have time. We have a lot of time to prepare. It's summer over here. The beaches are full of people. And they evacuate the beaches. And we have no victims. If you compare with Peru, you can look for some videos. In Peru, they didn't evacuate and they have victims and a lot of chaos in the beaches. So to finish, our vulnerabilities. There are always vulnerabilities, no matter which country are we talking about. We have to be humble. Inequality and lack of urban planning. I should say societal, ecological, economical, and other complex things. Poor people that they don't receive the $25,000 per capita, they live in any place, and usually risky place with bad construction, and that's a problem, okay? Ignorance and bad education and bad use of technology, like fake news. If today you can be very ignorant studying from internet. We need education for disaster risk management, for success. Inequality and lack of urban planning at all. Our old infrastructure, the maintenance of infrastructure. We have old houses, old buildings, but they are not safe for earthquakes, especially for big earthquakes, for the 9. So we need a bigger focus on that. We have to reinforce or demolish, maybe. I'm civil engineer, I prefer to demolish. Our transportation system is not good. Too much cars, too few trains, and etc. Too few bikes, but we are changing that. I'm sorry. We have to talk about our country, not just Chile, our countries, without anger and looking for the common benefit. That is governance. We need governance. We need the conditions to talk and solve these problems. It's a very political issue. In terms of vulnerabilities, we have a lot of people in the coastal areas. I will skip that. Capacities. We have learned from experience, as I can show, as I show you. We know our territory and we have good universities. We have science. We're doing science, not as much as we would like to, but we are. One language, I say it was good, but it's not so good when you consider immigration. In Chile, we speak a Spanish that is very difficult. If you come to learn Spanish in Chile, you will be the best all around the world because it's really, really hard to learn to understand us. So in case of immigrant people, usually are Spanish speakers from South America, but when non-Spanish speaker come here, there is a problem, okay? We can spend money, we have money, because, and this is very important because about 15 years ago, the government decides to keep save money. A fixed amount of money every year was saved. No, that will be used just in case we need it. So we save a lot of money, and last year for the pandemic, we navigated through thanks to that money. So that's a big good point. Not so much, but we have very good application of building codes and good control of building processes. Not so much corruption and very good building processes. That's a very important thing. We can make political improvements, slow, but we can, as I told you, 10 years and a large, etc. And finally, strategic. We have to be very careful with unknown hazards and local effects. Liquefaction, cortical earthquakes, shallow earthquakes, and many other hazards, especially those related with climate change. Unknown hazards. We have to be prepared. We have to be open-minded and think about that hazards. Also, open mind and tolerance. Maisa is the name of our new environment minister. She's the best scientist in Chile in terms of climate change. Will be minister of the new government since this Friday. And she said today, as was the 8th March, Day of Women's Day, she said that disasters has women faced because women always usually take the worst part because they are in charge of the kids, of the house, blah, 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 blah. So we have to think very carefully about how we build a better society. That will be good for disaster risk management. Education, I told you, a strategy, any strategy needs education. Investment, of course. Control and law, of course. We have to consider this to control and to impose law, physical and legal terms, and the most important, governance. This is a vulnerability tree, just a proposition, can be much more complex, and any of these issues must be understood and controlled, and if possible, improve. Thank you very much. That's all I had to say.
Okay, thank you very much, Professor Mauricio, for your lectures on a wide range of topics around the country in addition to tsunamis. I personally am very interested in the fact that ancient people in Chile almost got the mechanism of earthquake generation right by comparing it to a fight between two snakes. It's very interesting. Okay,
it's like the fish you have in Japan.
Okay. We are thinking that the earthquake is caused by the cuttlefish. Anyway.
Catfish.
Yeah, cuttlefish, yes. But unfortunately, we are running out of time. So, but if you can stay with us a little bit more, let's just one question.
No problem, I have time.
Yes. The question is not addressed, will be sent to the speaker. So could you show the question on the screen, please?
Here.
Okay. Could you explain more clearly? Sorry, question? Okay. Could you
explain?
Yes.
Okay.
CPAT and SNAM. Yes, please.
Okay, I'm looking for the slide. Are you not looking at my screen?
No.
CPAT, I'm sorry, SNAM. It's dependent on the Navy, and this is the big system that connects with the Pacific Tsunami Warning System. So it is designed to generate the alerts or alarms in case of tsunami from any part of the world, including Chile. Okay, but the CPAT is a system, a program, a software that you input the epicenter location and magnitude, and you get the evacuation area in the shoreline. Okay, CPAT is a tool that is used by the SNAM. Okay, that's the difference. I don't know if I answered the question.
Okay, thank you very much. We have a lot of questions, but unfortunately, this is a time to close the seminar. So again, I'd like to thank Professor Mauricio for sharing your expertise. And I also thank you very much for the participants for active engagement. As Professor Mauricio mentioned in his lecture, the volcanic eruption in Tonga and the following tsunami have reminded us that many countries facing the ocean are at a risk of being hit by tsunamis. And also, according to the news, another huge eruption occurred yesterday in Papua New Guinea. Fortunately, no tsunami has been observed so far. And also, the day after tomorrow, March 11, is the 11th anniversary of the Great East Japan earthquake, which caused a tremendous tsunami disaster, killed more than 26,000 people in Japan in 2011. So tsunami is not a frequent disaster in human time scale, not geographical scale, but once it occurs, it can cause a huge and widespread damage. Thus, we must always be prepared. So in this sense, today's lecture was really timely and meaningful. So ADRC will continue to promote tsunami disaster prevention by sharing experiences and lessons learned by in many countries. So thank you again. Once again, thank you very much for Professor Mauricio. And I think now you can see a voting slip on the screen now. I'd like to ask your cooperation for future improvements of this seminar. Okay, so this concludes today's seminar. We're looking forward to seeing you again. Thank you for your active participation. Stay safe and keep healthy. And goodbye for now.
And I'm sorry, if you need to send me questions, you can send the question to my email. You have my email if you can share with the participant in case any question need answer.
Thank you very much. Secretariat will send all questions to you later.
Thank you very much.
Thank you very much, Professor Mauricio.
Thank you.